Alright, I asked you guys to identify your A, B, C, and D. Cameron's not here. Daphne? A value? B is what? Yep. And we already found the C value, pi over 2. Pablo? When I find the period, what did you get? What's your B value? 1. So 2 pi over 1 is just 2 pi. Raise your hand if you got that. Let me use a color. Orange. Okay, this is the new part. So we have a phase shift because we see parentheses, and you have a C value. I'm going to come up here and everything to the right of the trig function, whether it's factored or it's not factored, all of it, you're now going to put that between 0 and 2 pi. Class, which side? Everything to the right. Let's do it together. X minus pi over 2. There are two ways to solve compound inequalities back in Algebra 2. You can either separate them into 2. Let me show you the 2. 1, 2, and then put it back together as your answer. Or you can do it all at the same time. Class, how do you get solve for x here?
Plus pi over 2 over 1.
Yes. Class 0 plus pi over 2. And then I have less than or equals 2. This one equals 0. Class, can we add 2 pi to 1 pi over 2? Nope. How do you make 2 pi a fraction? To get a common denominator, I'm going to have to multiply by 2 over 2. So this will give us 4 pi over 2 plus 1 pi over 2 gives me how much? 5 pi over 2. This now tells me very specifically where my x values are. Let's go ahead and draw our graph. Now, we normally did something like this. We did our 4 intervals or 5 x values. 1, 2, 3, 4, 5. But put your finger on the phase shift. The phase shift, the C value, is we're going in how much? Pi over 2 to the right. So no longer is the graph now starting at the origin, it's now starting here. You might be asking yourself, what is this value? This value is now pi over 2, and I have to make one more 5th point. That will be 5 pi over 2. So the reason why we're no longer starting on the origin, we're going to the right, pi over 2. So now I'm going to write pi over 2 and 5 pi over 2. I have a leading coefficient of 1. Class 1 plus 5. And 6 divided by 2 is 3. 3 pi pi over 2. Class, can you see a pattern here? What am I counting by? Ones. So this one's going to be what? 2 pi over 2, or just pi. Now, I'm just going to keep this for now, but I'll write the simplified one underneath. This might come in handy later. 1, 2, 3. What's this one? Which reduces to what? 2 pi. And the reason why I did that is kind of show these are all equivalent fractions in one row. I like to go back and now circle the ones that are simplified. And the ones that I'm circling are actually the x values we're going to use for our table of values. So, simple question. Yes or no? Class, is my first x value 0? No. Because we have a phase shift now. We had started for the last week. We always started at 0, but now we have a shift to the right. I'm going to write down the circled numbers. Pi over 2. Pi. 3 pi over 2. 2 pi. And 5 pi over 2. Now we're going to do the same thing as we did above. Class, which direction are we going? Right to where? Left. And essentially what that is just the order of operations PEMDAS. We're going from right to left. Class, what are we going to have to do with our x values now? We're going to have to what? Subtract pi over 2. Let's subtract pi over 2 for every value. Class, 1 pi over 2 minus 1 pi over 2. 0 pi over 2, which is 0. This is where it comes in handy. 2 pi over 2 minus 1 pi over 2. 1 pi over 2. 3 pi over 2 minus 1 pi over 2, which gives me what? 2 pi over 2, or just pi. I want to make it a fraction. Do you see it? 4 pi over 2 minus 1 pi over 2 is? 3 pi over 2. And then 5 minus 1 is 4 pi over 2, which is 2 pi. Thank goodness we got to the quadrantal angles. Okay, what did we do? I took my 5x values, and we're doing kind of mass production of simplifying, and we just subtracted pi over 2 from all of these values. Now, if I go all the way back up to the top, what do we have to do now? We found our x values, we subtracted, now what? We're going to evaluate at sign now. Let's evaluate at sign. Don't say anything. Partner B, tell partner A. Ready, set, go. What are you working on? Homework? Reading? Can you put your backpack down, please? Thank you. Jacqueline, what's wrong with that? Jacqueline's not here. Rochelle, what's wrong with that? The classic mistake. Raise your hand if you saw that. The reason why I did this on purpose is because every year a lot of students will make this mistake on a quiz or a test. This does not represent sine, this represents cosine. Remember, these are the quadrantal angles going around 0, pi over 2. So if you ever get stuck, don't rush. Think of your, for example, class, what's the order pair? Huh? 1, 0. X, Y, cosine, sine. Alphabetical order. Sine at 0 is the y value, which is 0. Class, sine at pi over 2? Pi? 3 pi over 2? 2 pi. Let's go ahead and graph that. Pick your favorite color. If you see your max and your mins, that means on your graph, that's what you're going to put up here. One student asked me, how do I know how many boxes? You can just pick whatever fits your paper. And now we're just graphing the order pairs.
If I do 2 boxes on the X, do I have to do 2 boxes on the Y?
Correct. Does that make sense? Because it has to be proportional. So here's my order pairs at pi over 2, 0. So pay attention. We're not starting at the origin. It's an order pair. Right, pi over 2, 0. Pi, 1. 3 pi over 2, 0. 2 pi, negative 1. And then 5 pi over 2, 0. And this is what my graph looks like. Let me fill in some more details that we actually have above, and hopefully that makes more sense. And then I'll show you guys one alternative way to create this table of values if you don't like my table of values. We graphed a sine x minus pi over 2, and do you guys remember that old period, 2 pi? It's a distance. What is it, class? Look at my fingers. What's 5 minus 1? 4 pi over 2 reduces to what? 2 pi. So the graph finishes within 1 period. Okay? The new period, I call it, or the one putting in the inequality, tells you a specific start point and a specific end point. We also learned about the amplitude, so I'm just double checking that all the information fits. The amplitude of a 1, it's from your max to the midline. Oh, that's interesting. Class, the x-axis is where on the y values? 0. Oh, maybe that's next week's lesson of just plus 0. Okay, that's where your midline or your d value is going to be. And let's just say you're like, Mr. Ng, this table of values is pretty complicated, so let's just pick something. Someone pick a value? Someone said pi. Watch this. This is what the table of values essentially is. Someone said pi. Class, what's pi minus pi over 2? And sine at pi over 2 is what?
0.
Sine at pi over 2 is 1. That's why my order pair says pi, comma 1. So you don't like my mass production table of values, that's totally fine, but you still need to figure out those 5 x values and just evaluate them. So this was a simple problem on a phase shift.